Yeah, hello, good morning, everyone. Today I have planned to cover these topics. Hope you are all able to see my screen. We'll see nested structures, array of structures, and generic pointers and dynamic memory allocation. So last week we saw what structure is. So we defined struct as some student or something. Within this, you have to add all the member variables of different data types like int, roll number.
Return.
No, I think so. Structures do not allow member functions to be included. But I have never tried. I just verify that
Yeah.
because that feature is that of oops. So C++ will allow you to add a member function. So structure, as you know, allows you to group data of different types under one name, and you can use type def to shorten the code and add a tag name here, let us say std. So you could have student as a structure name here as well as a tag name. So you can use this tag name to create an object of student type. So in main you can write like this stds like that. So one object of student will be created. We have seen all this. Now, can I nest the structures? For example, we know we have a customer and customer will have an account. So can I have account as a member of customer structure? So let's see how can I do that. So let's first define an account type struct here. So as you know, account will have account number. So int. So this is my first structure. I would like to tag it as account. And another structure, customer. Now customer will have customer ID, customer name, maybe his age. Now as a member here, I can have account as cust account, something like this. Should be possible, right? Because this is user defined type. Along with the primitive data types, I can have user defined type also. This should have been struct here, and the tag should have come here, customer. So what I have done is I have added three primitive data types: the int cid, char, customer name, int age. Now the fourth one is a user defined type, okay, which is of type account, which you have declared here. So this should be type def here. Type def struct int account number float balance. Now if I define a nested structure like this, the nesting is coming because customer must have an account and account is a member of customer type. So in the main, how do I declare a customer account? So I just say customer C. The moment you say this, uh, an object is created in the memory. You can imagine all of that. So first part is your customer ID, then second is your customer name, third is your age, and fourth one is a account, which is customer account here. So the memory for this member variable will also be allocated when you say customer C. You don't have to separately allocate memory for the customer account, which is user defined type. Okay, so now how do I initialize the customer with all the values using the dot operator? As you know, cid equal to 100. Okay, c dot c name equal to some Kiran or something. Of course I should use a string copy here. I cannot do like this. So just for simplicity I am doing this, but in the code I'll show you how to do that. Then c dot age equal to, let us say, 22. Now this account, okay, which is customer account, how do I access that? So I should say c dot cust account. Okay, in this there is
Number.
account number, right? So what is the member variable I use here? Account number. So ACCT here ACCT let us say some 2001 customer account. You should first access the member variable, which is customer account, and within the customer account we have a member variable balance. So let us say some 5,000 like that. Float. Okay, so now I have initialized all the primitive data members of customer and also the members of account type which I have used as a member variable. Okay, using the dot operator. So as you can see, you have two dots here. One for accessing the member variable, and then second dot is for accessing the member variable of the customer variable or the account variable, which is customer account. Okay, so we should be able to do this kind of a nesting, and it is useful to have nesting because as you know, account is an integral part of customer, isn't it? So why does a customer exist? Because he has an account. All right, so you can do nesting of structures as and when it is required, right? So there are many practical applications where nesting of structures is a useful concept, right? So let's see the demonstration of this quickly. So first thing is I create type struct. So first one was our account. So int account number. You can give a lengthy name like that, then float balance. You can have other members as you wish, like account type, etc. But for now, we are avoiding that. So this is an account structure. Okay. Then we need to define, and within the customer, we have customer ID, then customer name, 20 characters. Then you can include other members, age, right? Or you can include gender here. And then finally, we need to define a user defined type member variable account. You can call it as customer account like that. So we see a nesting of structures. So there is one structure member variable inside another. All right. Now here we need to create an object of customer type. So customer C. So memory is allocated for customer account or other customer object, and within that we have three or four member variables which are primitive type and one user defined type. So to initialize, we can say c dot cid equal to 100. Then c dot yeah, here I have to use string copy. You have c dot customer name comma some name here. Then c dot age equal to 26. Then c dot gender equal to male. So m in single quote because it is a character. And now if you want to access the user defined variable, which is customer account, you have to use two dots. Okay, so account number, you can assign some long number like that, and then c dot customer account dot balance, some balance. Okay, so now the complete object is initialized. If you wish, you can display this. So printf percentage d, which is for customer ID, then percentage yes for customer name, and we'll display only few fields here. Gender will display, then account number again is percentage d, then again we have balance, which is percentage. Yeah. So c dot cid, c dot customer name, comma c dot gender. I am not displaying the age deliberately, and c dot account number, and c dot customer account dot account number. Okay, you cannot directly access account number. Hmm. Again, last part is c dot customer account dot balance. Yeah. So now if I run this program, I should get 100 GBHM like that. So error is coming because we have not included library function for string copy. I should say hash include string.h here. Now, as you can see, there is a customer with ID 100 GBH is a male, and his account number is this and balance is this. Okay. So any questions here? Is it good to proceed further?
So can we try this?
If you wish to try, yeah. Okay, go ahead. So here the customer has four member variables. First one is CID. Second is a customer name, is an array of characters. Third is age, and fourth is again an array of characters, which is date of birth. So we can declare array of user-defined type just by using a square bracket after the variable name. So customer is a user-defined type. All customers is a variable name, and in the square bracket I am giving 5. So here you can give just 2 because I am using 2 only, 0 and 1. And you can read into the customer ID, customer name, date of birth and age. CID and name, CID and age are integers, so that is why I have to pass the address of it. Name and date of birth are strings, so no address operator is required. And after the loop, you would have read all the values of the member variables for both the objects, and you can call display customer info by passing the array. Just observe in the display customer info, I am passing just the array name. And since display customer info is not returning anything, there is no return value. And in the display function, you give a heading before the loop so that the heading appear only once. Separate the column names with /t so that all values are neatly aligned. And in the loop, you display all the member variables with appropriate format specifiers. So once you are done, let me know in the chat box if you are done. Are you able to see my screen?
Yes.
Yes.
Okay.
Yes.
So this view is enough, or I should scroll up or down? In programming, practice is the main thing. So I don't know how you uh, find time. We have to practice the programs. Only then you'll be able to confidently write the code. Conceptually, you'll all understand it well, but when you practically try to do it, one or two mistakes here and may happen. It may throw some errors or warnings, and little debugging has to be done to get the program working. All of you are able to follow what has been discussed today? Ashwini?
Yes, sir.
Okay. Faisal?
Yes, sir.
Nikita?
Yes, sir.
Okay, good. Pooja?
Yeah, yes, sir.
Okay, good. Shilpa?
Yeah, yes, sir.
Okay, Vinod?
Yes, sir.
Okay,
Today's one very good.
okay, that's good.
Sir, I have done like this, sir. Like I have created a struct for date,
Hmm.
int, day, month.
Oh, okay. Even that is fine. Hmm. Yeah, you can do nesting there. That's the most appropriate thing to do. My intention in this exercise is to show you how to use array of structure objects. So I have deliberately avoided that nesting.
Sir, one more thing. Here we'll call a subfunction like that, that void display.
Okay.
Here, the argument, we have to give the same name, right? Like whatever the structure has
No,
been
no, no,
defined.
no.
That
This
void
can be
display.
anything. This can be X here.
Oh, okay.
This is only a
Oh, it
place.
can be.
This is only a placeholder.
Okay.
Okay.
The same like how it is then for
Yeah,
the other
yeah. How
function.
it is there.
Huh, okay.
Only thing is, if you give the same name, you understand the meaning of it. Otherwise, if
Huh,
you give
yeah, yeah.
any random name like that, X or Y or whatever,
Okay.
it should still work. Now, the tab, single tab won't help because this DOB is lengthier. You can give one more tab here while displaying so that age gets aligned with the actual values. So, 2 slash T you can give.
Sir, just one question.
Ah,
So, what would be the prototype for this function prototype? Because we are not
we have done
okay. I
function
saw this.
void
This one.
display customer info. Customer is a
Oh,
user defined type square box. Here it has to be customer.
okay.
Okay, because you are saying data type and then whether it is array or not.
Okay. So, this has to be the structure name that we
Yeah,
define.
you can
Customer of.
put x square also. That is not really
Mhm.
required. You just have to say it is an array.
That we can do,
You
right?
can you can do you can do, but
Okay, no, I'm just checking, like,
yeah, yeah,
can we do that or not?
you can do that.
Okay.
Yeah.
So that it will be easier
Yeah, it is
rather than
easier, but my purpose
lengthy.
was to demonstrate the use of a nested structure. Okay, you
Yeah.
can draw some analogies from Python, so how it was done there and how it can be done here.
Right, right, right.
Okay, okay. So shall we proceed now? I think so. All of us done. So you are in touch with programming, then you will not forget those things. Otherwise, same mistakes keep occurring. Okay, good. So conceptually, you know the usefulness of structures, how I can group data of different types under one name and use it to build an application like that. Okay, so next thing is, can I allocate memory dynamically? And Faisal had a question, what is that void star? Okay, so we'll see void star, a generic pointer and how it can be used. Now there are two ways of creating structure variables. One is through defining customer C and then reading customer ID, name, etc. Another is I can create a pointer here. Okay. So can you tell me what is the difference between the two? What is customer C and what is customer star P?
C is directly object and star P is the pointer
Pointer. How much
of
memory?
type customer.
Okay. How much memory is allocated for C?
For C, it is 2 and 22 and 24 and 44.
Uh,
For C, it is 44. For P, it is um, just one the address byte, meaning
okay.
it is like
Now, if you are
2
assuming
bytes,
integer taking 4 bytes, then CID 4 bytes, age 4 bytes, and
right?
these 20, 20, 40. So 40 plus 8, 48
48, yeah.
bytes will be allocated for C.
C.
But if I say customer
So,
star P, P is a pointer, only 4 bytes are allocated.
right,
Okay. Now, P is a pointer, it's not a object of customer. You need to provide address to P, P should point to allocated memory, and this time I'm going to allocate memory for P not through AND C but using a dynamic memory allocation. So there is a function called as malloc. So what malloc does, it will allocate memory for an object of a given type. So here you can say size of customer. So what this size of operator does, it will calculate total memory required for the one customer object. So now we manually calculated as 44, right? 48. So 48 bytes will be allocated, and this malloc function if you see the description of malloc function, it is void star malloc, and here it is expecting some size. If you see the function prototype of malloc, it is returning void star. Now if I try to do p equal to malloc size of customer, it throws an error that void star you are assigning to customer. So you have to typecast this appropriately as customer star, so that this pointer p understands what are the constituents of the customer. That is, first part is an integer, second part is an array of characters, third is an again integer, fourth is a again character array going up to 20 bytes. So when you typecast, P knows how to interpret the member variables inside the structure. Otherwise, if you don't typecast, P does not know how to interpret the first part, second part, third, fourth, like that. Okay. So if you provide a generic pointer, it is simply array of bytes, 48 bytes. So if you say printf percentage d p arrow cid, then it doesn't understand what how to extract cid here. Okay, if it is not properly typecast, so you must typecast here customer star. So the white star is converted into customer star because p is of type customer star. And now p understands that first member is of 4 bytes, it will print that. Now before I print, I should say p arrow cid equal to some value here. Okay, so now if I just run this, you will see 100 will come. Okay, only thing it is throwing an warning that you have not included stdlib in which malloc.h malloc function is defined. So hash include should come stdlib.h. If I run this, you get 100. Okay. So likewise, you can initialize other member variables with an arrow operator because p is a pointer. If I'm using normal variable c, it should be a dot operator. I should say c dot cid. Now p is a pointer. I should use arrow here, and then you can say customer name. It should be you should be using string copy. You cannot directly assign string to this member variable. Let us say some name. So this is yeah, string copy like that. So customer name is initialized with this name, and then p arrow age some 22, and then string copy again, p arrow date of birth comma, let us say 22/9/1997, something like that. So now all the members of the structure are initialized, so I can print them here. Printf percentage yes comma p arrow customer name. You can leave a little space here using /t. Similarly, printf next is age percentage d/t p arrow age. So p is missing here. Yeah. P arrow age, then printf percentage yes again p arrow date of birth. Okay. So instead of statically allocating memory, I am doing it dynamically. That is when the program executes this statement, the statement at line number 24. At that time, memory is allocated to the pointer p. Until this point, that is till point line number 23, p is just a hanging pointer or dangling pointer. It is not pointing anywhere. So only at line number 24, P gets assigned to memory block, which is allocated by malloc. And after at line 26, you are initializing the member variables and then you are printing like that. So if I print this, it will correctly print that. Hmm. Only thing, one more slash t was required here. What happened? The slash t should be here. So we used generic pointer, and whenever generic pointer is there, it is always required that you typecast it. If I don't typecast, say, let's see what happens. It works because here uh, it is able to work this time. Malloc gives a generic pointer white star, but typecasting, yeah. Now it depends on the compiler. Okay, sometimes some compilers know that P is of type customer, it will automatically typecast and provide you that typecasting, but it may not work on all the compiling platforms. If you go to Turbo C compiler, it may throw an error or print some junk values when you try to do that. So it is always safe to put the typecast here. Hmm. So customer star. So typecasting is not an error, but it is a bug. It may work on your compiler, but if you port it to some other compiler, it may not work. So always it is advisable to typecast the memory allocated by malloc to an appropriate type. That is exactly the type of the left-hand side variable. So P is of type customer, so you must typecast into customer and use it so that your program is safe and easily portable. Okay, so that aspect you have to take care, right? This part is clear. Dynamic memory allocation and that void pointer.
Sir, can you give example for one example for primitive data types like int or
Oh, okay. So what we can do is, let us say there is one example I saw. You can say void star. mm, what can be the name of that? Mm, get me. You can give any name, and then here you can pass star type. So if type is integer, I'm going to allocate 4 bytes and send a generic pointer which you have to typecast. So you can do a example like this. So here I check if string compare type comma int. If you're passing int as an argument, when the match happens, it will return 0. So if this is the case, I am going to take an integer pointer here and say p equal to int star malloc size of int
So string compare, right? It is string copy here. strcmp.
string compare, sorry, string compare cmp. Yeah, okay. Now you can store some value here, let's say 14 or something, and before you return you should say return uh, void star p, because the return type is generic. Okay, so after I have done all this, I must put all of this block into, and if you are getting another type, let's say strs compare type comma what do you want to put, float equal to 0. Then you have to do almost similar thing, just taking a float type pointer and do that. Instead of int you say float, here float star, and here it should be float, and here should be some real value, and then again return white star. So now I am returning a generic pointer from this function when I say get me. And in the main, when I call this, so here in the main, when I call this, suppose if I want int x equal to, okay, get me, here if I say int, it means it's going to give me an generic pointer and I must typecast into int. If I want int star, this has to be star here. Okay, so we are returning a generic pointer and it is typecast into x. Now if I say printf percentage d or x equal to percentage d, then star x, it will print that 14 that you have initialized there. Only thing is I have to now write the prototype for this void star get me char star. Okay, so let's see whether it works for me. X equal to 14, isn't it? So you can put a slash in here so that it comes on the next line. X equal to 14. Now if I make it float here, then I have to convert it into float, and here I should give float, so that this time it's going to display the real value which is assigned, and that value, if I see, what is it, 14.55. Okay, so I've written a function which returns a generic pointer, and depending on what you are passing here, accordingly you have to do the typecast and take it as the left hand side. Faisal, is it clear now?
Yes, sir.
Okay,
We'll try this out.
so just try it, give a try both the things using a malloc function dynamically allocate space. Try this first part and then write the get me function which returns a generic pointer, and you do the typecast.
Sir, actually, in that void star get me, can you repeat me like why the return type is void star of P, sir?
Yeah, this has to return uh, a generic pointer depending on when I'm passing different types, no, float, and I'm using the same function to get memory allocated for either float type or integer type. I am not writing
Okay.
separate function get me int, get me float like that. Same function has
Okay.
to return me pointer of different types depending on what I'm passing.
Okay.
So you cannot write float star here. If you do, when you pass int, then there will be conflict, right?
Correct.
Or if
Correct.
you write
Yeah.
int here, when you want to return float, there will be a problem. So if I say void star, depending
It
on
can be
what you
anything.
pass, you can pass pointer of any type. And you must
Okay.
appropriate typecast here so that left hand side knows how to interpret the data, whether as float or int.
No, sir, this is void star is okay. Below, sir, if you come below, there also
Yeah.
have given a return of void star. I mean, like already we have mentioned in the beginning of the function only, no, like it's void star. Why do you want to mention here also
Yeah,
like
now
return type?
see, P is of integer type, no? If I say return just P, then P is of type int star.
Okay.
So again, you have to typecast into void star, no?
Okay. Uh-huh. Uh-huh. Okay.
To make P
Okay.
generic, you have to do typecasting
Generic.
of P also.
P also. Okay.
If I don't
Thank you,
do
sir.
this and try to do this, like
Yeah.
now what happens is there will be a mismatch.
It throws
It will throw an
yeah.
error. Hmm? So you can
Correct.
just try
Okay.
that. This should be void star. Similarly here, P is again
Huh.
float type.
Yeah.
It has to be
Float. Yeah.
typecast into void star so that the return type is void star, and when in the calling function you must appropriately typecast depending on what you passed here.
Okay.
Hmm.
Got it, sir. Thank you.
Sir, we should also free that dynamically
Yeah, yeah,
allocated memory.
definitely. You should say uh, free P. Here I use, now after use of P, which is a 48 bytes are freed up. Otherwise, uh, the problem is the memory leakage happens. If the program terminates, even the memory remains allocated. So if you run this program several times over, the memory gets accumulated, and you will reach a point where there is no memory left. Okay, so that's called as memory leakage, and you must free up that also. So here also you can say free x. Free x is not required because it is a pointer. Only memory allocated dynamically, it has to be freed up. Yeah, even you should say free x because you are allocating memory dynamically here also. Correct?
Yeah,
Yeah,
Mac.
so
Okay.
both are required. Wherever there is malloc, the corresponding free function should appear. In Java, it is done automatically. So there is a program called as garbage collector, which will keep checking if any object remains in memory even after program is terminated, it will deallocate.
Okay. So, but we don't get any error or
No, no,
anything.
you don't get error.
We don't declare free.
Yeah, yeah. That is why I told C gives you a lot of freedom, but it will put
Yeah.
responsibility on you.
Yeah.
Okay.
So, can you go?
Up.
Yeah.
If you are done, type done in the chat box so I know that you're trying all these things out. Now, one more thing, we know that customer takes 48 bytes. You, instead of size of customer, you can write 48 here directly. But this is not advisable because if you move this program to some other operating system where int is 8 bytes, then it doesn't work. Okay, so that is always better to write size of then your user defined type. Hmm? So I've declared C, but I'm not using it. You can drop this. I just typed that to show you the difference between what is customer star P and customer C. For customer C, the variable C here, the memory is allocated by the system statically. So this is static memory allocation. Now there is one good practice that you must follow, that if whenever you do dynamic memory allocation, check whether this is equal to null. That means if there is not enough memory in the system, it will return null. So you can say printf memory allocation failed. Okay, and you can just return from here only. You don't proceed further. Return -1. Otherwise, you continue. This is a good practice. -1 indicates that there is something wrong with your program. You can try taking another pointer y of type int. Then here you have to say int star get me, in bracket I should say int, so that it will allocate 4 bytes for integer and interpret as integer. And if you want to print y also, you can do that. Print f. So I'm calling get me 2 times, one time with float, one time with int, and accordingly it will allocate the memory. Int 32 bits, and if float is 64, it will allocate like that, and it will return pointers, which is generic. You have to typecast and use. So to summarize, what we learned today is how to declare a nested structure and how to access the member variables. And member variable can be of primitive type or user defined type. So if it is a user defined type, if the member variable is a user defined type, I will be using 2 dots there. And we looked at area of structures. Okay, so where we can allocate memory at once for more than one object of a user defined type as an array, and how to read into array of objects and display them in a table of form. So that was one of the exercise in my assignment before that you try it out. That was an employee example similar to the customer here, and you can submit that. And we also saw how to allocate memory dynamically using malloc function, which returns a pointer of void star or the generic pointer. And you need to appropriately typecast to assign it to a variable of particular type. In this case, P is of customer type, and hence I'm using customer star. And we just now saw a function, our own user-defined function, which is returning a generic pointer. So this will allocate memory to either an integer, float, or char, or maybe double. I need to expand this program to do that. And it should return a generic pointer. And depending on what you have passed as an argument, you should appropriately typecast in the main to receive the pointer of particular type, like float star x. Okay, so likewise you can take x and y, which are of type float and int respectively, and print them. Okay, so this is what I had to cover today. The more on structures, pointers, and pointers to structures passed as argument to functions, that we shall see in the next class. Okay, yeah. Shall we close for today?
Thank you. Ah, sir.
Yeah, okay. Thank you.